Okay, so we should be able to convert these now to radians and then draw them in standard position. Now you can do it, draw them in standard position and then convert them to radians, or you can do it the other way around. We want to start getting used to radians though. So I'm going to convert this to radians first. So I want to get rid of the degrees, so I'm going to divide by degrees and times by the radians. So this is a special angle, so I want to get rid of the common factor of 30, and I get 7 pi over 6. So 7 pi over 6 locates that position right there. And it gives us this 30-60 triangle in here. That reference is going to be really important. Negative 120. I'm going to convert this into radians as well. I've got a common factor of 60, so I'm going to end up with negative 2 pi over 3. Negative 120 degrees is going to end up in this position over here. Okay, so it's going to be on the lower side of that 45-degree angle in there. This is going to be on the other side of the upper side of the 45-degree angle. So there's my rotation, and it's negative 2 pi over 3. Okay, pi over 3 is 60 degrees, so I've got two groups of 60 degrees to go in there. Okay. So these ones here, again, we want to draw these in position. Okay, now if you have to convert that to degrees, that's fine, but we should start thinking of how knowing these radians. So that's going to be 1 1/3 pi's. So there's 1 pi. 1 1/3 pi is going to go 1 1/3 pi. It's going to be right about there. Okay, it's going to kind of be below the 45-degree angle there. So that's going to be 4 pi over 3. That's going to be 240 degrees if you convert it to degrees. Now, if you need to convert to degrees, that's fine. Okay, we also want to start getting used to the decimals. We need to at least know the quadrant that we're in. Okay, so negative 233 degrees, sorry, 2.33 radians. Positive 2.33 is going to go through one quadrant and just midway through that next one. Okay, probably about halfway through. So negative is going to go in this direction. Okay, it's going to be about there. Okay, now with the decimals, it's going to be a little bit harder, but as long as you're in the right quadrant, okay, that's fine. It also asks you to draw in the reference triangle. Okay, that one's a 30-60 triangle here. This one we don't know. It's not a special angle, so we don't know. But there's my reference triangle there. It's always made with the x-axis. Okay, we don't draw our reference triangles this way. Okay, we always make our reference triangles with the x-axis. Okay, so we can do these problems that we did last day. And the only difference, there's no difference except for if we ever need to find the angle, we need to then make sure that we're in radians. But the picture is still the same. This is still opposite over radius, or hypotenuse, or y over r. There's my picture. There's my theta. Okay, now if you were to look at that, that's 30 degrees. Okay, we want to try to get familiar with that ratio. There's our picture. Here, this is in quadrant 4, so this is going to be 2, I think 2 and 3, maybe more like that. Actually, I think it's going to be more like this. Okay, so that's 2, 3. Okay, there's our theta. Okay, and we have our triangles here. I'm just going to highlight the triangles. There's our reference triangle to work with. Okay, it's always made with the x-axis. There's our reference triangle to work with. Okay, now it doesn't ask us to find the angle, but this one we do know the angle. It's 30 degrees. So if I were to ask for theta, theta equals 30 degrees. Now 30 degrees is pi over 6 in radians. This one here is not a special angle, so I need to actually use my calculator. So anytime I use my calculator, I sometimes get the right answer, sometimes I get the answer in the wrong quadrant. So I got to be careful. So I'm going to do arc cos. Now to do this though, now this is where things change. You have to change your mode. You have to change your mode to radians. Okay, and in fact we probably should just keep it in radians from now on because we really should do everything in radians. So I'm going to do arc cos, and if I do this in radians I get arc cos 2/3 and I get 0.84. Theta is equal to 0.84 radians. Okay, now the problem is I'm in the wrong quadrant. So theta 1 is the wrong angle. Okay, so I still have to remember this theta 1, theta 2 thing. Theta 2 is, I want theta 2. I want to go backwards. I want to go in the negative direction. And I'm going to use a symmetry. I know that I don't want the positive one. I want the negative version of this. And there's my angle. If I did this in degree mode, so if you didn't change your mode and you did this in degrees, you would have gotten 48.19 degrees, which is fine. That's the right answer, but it doesn't give us the radian version. Now, some people like to just take it to degrees and convert to radians, but we really should just work in radians. We should set our mode into radians. Okay, so we'll do the last couple ones here. Sine, this is going to be 0.866 to 1. Okay, it's a one number ratio, so always compare it to 1. So I'm going to do arc sine. Make sure my mode is in. Actually, it doesn't really ask me to find the angle. Okay, but I'm going to find it anyway. Let's do it. 0.866. Okay, it's going to be 1.05, it looks like. So theta, and that's the right spot, 1.05 radians. Okay, so that looks about right. That's going to be 1.05 radians there. 2.24, probably a slope that looks kind of like that. It's in quadrant 3, so I'm just going to stop there. There's my 2 point. Oh, this is not, yeah, we don't know theta. But there's my slope. It's going to be -1, -2.23. And there's my picture. And if I want to find out the angle, I just do arctan of 2.23. And that's going to be 1.5. Theta 1 is 1.5. Okay. 1.15 radians. Problem is that's in the wrong quadrant. Okay, that's going to be 1.15 right about there. So again, I have to worry about the theta 2 issue, but I'm going to use symmetry to get the other angle. To go to the other side of the circle, I'm going to go 1.15 plus halfway around the circle's pi. So that's going to end up giving me 4.29 radians. Okay, so that's how we get to that theta 2 value on the other side of the circle. And this is the one that we want, right? That's the black.